Hi everybody, this is Lisa Johnson and I'm going to be talking to you about the topics of phenology and degree days. Phenology is a really interesting subject and plays right into the organic techniques lecture, and we're going to be talking about the topic of phenology and how it fits into the ways that we use different strategies to help with pest management in our gardens, whether it has to do with actual insects or whether it's about diseases. So the idea behind this lecture then is how we use these plant, insect, and disease developmental cycles to improve our pest management techniques. So phenology is derived from the Greek word meaning to show or to appear. Think about garden journaling here. The idea is that phenology takes ordinary processes that happen every year, like the first robin returning or when the first lilac blooms, and correlates it to growth stages of other plants, animals, insects, and disease organisms. The neat thing about this is that when we have bizarre weather patterns like we had in 2012 and 2013, we can still figure out what is going to happen when based on these patterns. It's really difficult sometimes when people call up and they ask me, can I still put down crabgrass preventer? Or is it time yet for me to do certain things in the garden? And I can't always tell them based on a calendar date because weather is so different. This year we're about 2 weeks behind in 2013 from what our quote normal unquote temperatures would be. Last year at this time we were probably at least 2 weeks ahead, so it was a little difficult to predict things. However, phenology can help with that. So phenology is an ancient science, and this science has been used to determine when to do crop planting, when insects are going to be developing, etc. So you may have heard some of these in context of Farmer's Almanac or just an old saying your mother or father or grandparents might have said, or even great-grandparents. An example is to plant corn when oak leaves are the size of a mouse's ear. Now, the oak leaves are going to develop based on when the temperature is right, and so you know that your corn, as long as it's linked to when the oak leaves are a particular size, that it's okay to plant. If I tried to give you a calendar date to do that, sometimes that can be a little difficult. So the idea of using phenology is that even when weather delays or accelerates events, they're still going to coincide with each other, if not the calendar dates. And the reason for this is partly evolutionary in that insects, for example, are pests that have their development related to the availability of their plant food source. So if they hatch out too early for their food source to be available, they don't live very long. And the insects that do hatch out at the appropriate time and do have the appropriate food source are going to be the insects that survive to breed for the next generation. So those that follow the correct developmental patterns are going to be successful. Here's an example of a phenological indicator. So the Japanese beetles are going to be coming out soon. Usually we see them somewhere between the 23rd of June and the 1st of July. But sometimes it's a little earlier or sometimes it's a little later. But if you remember to look for the chicory blooming alongside the roads, that beautiful kind of cornflower blue flower, about the time that that starts to show up, you should start looking for Japanese beetle adults. The two are correlated. And they're actually correlated because of degree days, which are a measure of heat units that we're going to be talking about in a minute. But the nice thing is that both of those events correlate with each other because they both need the same number of degree days. Therefore, you can use one to predict the other. Here's another example. Bronze birch borer larvae are hatching when the arrowwood viburnum is beginning bloom and pagoda dogwood is in late bloom. And right now in the teaching garden, the pagoda dogwood is losing the last bits of its bloom, and the viburnum, the arrowwood viburnum, which is in front of our classroom window, is in full bloom. So if we were able to find any bronze birch borer larvae, they would be hatching out. Now, phenology also has global indications, and these data are being used all around the world for global modeling around the topic particularly of climate change. Climate change, we are now doing a lot of study about that at UW Extension and other extensions because we know that as the climate changes that there are going to be big changes in agriculture, there are going to be changes in forestry, there are going to be changes in fishery, and even in public health. For example, with public health, when you have different temperatures and you have different rainfall regimes, you may get an increase in things like malaria. And so knowing how those weather patterns are going to affect the development of that particular insect and having it, the mosquito, move into different areas is important. Also, Phil Pelletieri will talk to you about the movement of ticks, especially ticks that carry Lyme disease, and how that has changed with the climate over time. So these phenologists work together then on national and global scales to bring the idea of phenology and technology together so that they can share with each other what's happening in their bailiwicks and be able to better predict when different phenological events are going to occur. We do this in a small way. We have a weekly meeting with the horticulture team, and the different counties report in on what's happening in their areas. When the magnolias, the saucer magnolias are blooming, when they see Japanese beetles, when we have all kinds of different events occurring. And that helps the rest of us to know what's going on in different areas of the state. The pest bulletin that I've been pushing all year long too also has a section that goes into degree days and also talks about pests in terms of phenology, but also in terms of degree days and what's coming up and what to look for. We do have a fact sheet on phenology that was written by Karen Delahoe, and it's a really nice and short read, so I'd recommend that you take a look at that. It's just 2 sides of one sheet and talks about the history of phenology and how it's used. If you're interested in phenology as a topic in general, you might be interested in joining the Wisconsin Phenological Society, and I've included a website and contact there. Also, if you're interested, there is a really great book called Coincide that is written by Donald Orton, and you can get that through Amazon.com or another online source, and it's about an inch thick, and you can see all different kinds of plants and what insects are problems on them, and phenological events that you can use to track those insects. It also goes through degree days for many of the insects, and at what stages, and what stages match up to what degree days. And that segues perfectly into talking about degree days and why phenology works. As I've already mentioned, plants and insects develop in response to temperature that is measured in these thermal heat units that are called degree days. And usually these degree days start accumulating sometime in March, and they continue through the growing season. The warmer the weather, the faster the plants and insects are going to develop up to a point. That point is usually somewhere around 86 degrees. Many plants will kind of start to shut down at that point, and many insects also will sort of have the same sort of thing happening. But the cooler the weather, then the slower they develop, which explains why some years we see certain insects coming along more slowly than we typically expect to see them. And of course, in other years they appear sooner than we normally expect to see them. And Japanese beetle again. Here we've got an example. You can see that the adult beetle in the chart is kind of appearing right around July or the end of June when it is an adult. Now I'm still digging up in my yard and here at the teaching garden fully developed grubs, but not the pupal stage. So we might be lucky and they might show up a little bit later this year. But I've also noticed that the chicory is kind of on schedule, so they may not show up a little bit later. That would be typical for Japanese beetles. And Japanese beetles, of course, have a fairly long life cycle when they are active. So that makes them all the more difficult to control. Here's some examples from last year being such an unusual year you can see the effect of degree days on Japanese beetle development because they showed up at a different time than normally would have been expected. This data is from Purdue University, and they had confirmed Japanese beetles for the first sighting on May 24th in Indianapolis. And you can see below, listed under the bullet points, the typical time that they would be first sighted. And so these data show that the beetles were coming out quite a bit earlier than would have been expected. Now it's not all apples to apples because some of them are at slightly different areas, but anyway, you get the gist of the idea. Okay, then why phenology works is that it's based on degree days. And the degree days are again a heat measurement that incorporate time and temperature into one single measurement. Now, the degree days have a temperature threshold, a minimum temperature threshold, and beyond that development stops. So below 50 degrees, for example, which is often represented as DD50, you wouldn't get any insect development. Now, not all insects adhere to that. There is a 48 degree day measurement as well that is sometimes seen. But the most common one is 50 degrees, and that's what we'll be using for our purposes. So degree days, I mentioned that they usually start to accumulate sometime in late March. They start to accumulate when the temperature exceeds this base or minimum threshold of 50 degrees. And there are ways to calculate it, and we're going to go through that in just a minute. But I wanted to stress that one of the reasons that degree days are useful is if an indicator plant is not nearby, or if you want to be able to compare conditions in different geographical areas, like between us and Waukesha County or between us and Janesville, for example. It's really important when you have an indicator plant that's also not been matched with a particular event. So if you have an insect that doesn't have its development correlated with the development of a particular plant, then you need to use degree days instead. So once again, a plug for the Pest Bulletin. The Wisconsin Pest Bulletin tracks degree days statewide in Wisconsin, and we start to get that usually in April, and it runs through early November. And again, it is free for you to subscribe to online, and you would get that emailed to you, and it does have a chart with degree days. Now, it's not exact because usually degree days are recorded at airports in the cities in which they take the measurements. And for example, in Madison, the airport is on lower ground actually than quite a bit of the city. So sometimes it's a few days or numerals behind where you may be, but it's a really good ballpark for what's going on around you. So this is how you do it. It's really easy. If you are able to purchase a minimum maximum thermometer, and you can look that up on Google, a minimum maximum thermometer has actually two thermometers in it. One will measure the high temperature for the day, and the other will measure the low temperature for the day. And they have these little plastic markers that will ride up the mercury stream or whatever is being used for measuring the temperature, and then stay at whatever the level was, and then you move them back the next day. If you go out in the morning and you check them, you can see what the minimum and maximum was for the previous day. You move the little markers back to the top of the mercury column or whatever is again being used, and that resets it. So what they do at these airports then is they go out and they check the minimum and maximum temperature, and they find the average daily temperature by adding the daily high and low temperatures together and dividing by 2. So that's pretty easy. After you've got your average daily temperature, then you will subtract the base temperature, which in our case is 50, from it. So to calculate that, if we use an example, say the average daily temperature was 60, and you would add it to the base, and then you divide by 2. That's how you get your average daily temperature. And then so that 60 would be the high temperature and the 50 would be the low temperature for the day, just like in the example above, and then you divide it by 2 and you get 55. Now if it had been 50 and if it was below the low temperature or the minimum temperature threshold, when you divide by 2 and you get something that's less than 50, then you don't accumulate any degree days for that day. But in our example here, we're finding, okay, our average daily temperature is 55. You subtract the base temperature from that, and you get 5 degree days. Woohoo! So some days you'll get 5, some days you'll get 10, some days you might even get more. It really depends, and it's going to jump around quite a bit. So you could do this at your own home if you wanted to. But otherwise, the Wisconsin Pest Bulletin does record it at the airports of these particular cities, and sometimes they're recorded in orchards, and they have other contributors who provide that information. So this is an example from the Pest Bulletin, and the example from the Pest Bulletin is from last year. And you can see I drew a red line under the 50 degree column on the date of May 30th. We were at 801 degree days. Now if you contrast that to the year before, 2011, we were at 383 degree days. And the normal for that date is about 527. So you can see we were quite a bit ahead last year, which I'm sure will come as no surprise to anybody. And they also have two columns that show if you're using the base of 48 or 40, you can see what the numbers were. This year, for the date of May 30th, I looked at the Pest Bulletin, and I believe we were at 400 degree days. So we weren't quite as cold as we were in 2011, but still pretty darn cold compared to the normal of 527. And these normals are calculated in about 30 to 50 year averages, so they do change the normals as the climate changes. So this is an example from the Pest Bulletin from last year about how you would use that information. So the Pest Bulletin takes a look at the degree days and can predict when the emergence of certain insects will be if the current weather pattern stays the way that it is. And they have something that's called a biofix that is used to kind of figure out when these things are going to occur. So the adult emergence then is expected from 2012 to begin by June 5th in the far south. A few days later then was last predicted, apparently because the weather was a little bit cooler, or maybe we had rain or something. And so what they do, taking that insect's life cycle and the degree days, is tell you to start examining foliage and stems of pumpkin, squash, and other vine crops for eggs and evidence of feeding from 900 to 1000 degree days, and then apply controls when you first see the adults. Controls would be things like sprays, in the case of the squash vine borer, or potentially nematodes injected into the squash vine, predatory nematodes, before the larvae bore into the vines. Another thing that you could do is you could wrap the base of the vine with aluminum foil up to about 12 inches, and that will help discourage the squash vine borer from laying its eggs in the vine. Now, in areas of the state that we have emerald ash borer, such as in here, West Bend, they noticed the adult beetles were coming out about 12 to 14 days earlier than the previous 2 years, and give a little information about what you should do if you're in an infested area. So that's kind of how degree days are applied to particularly help the commercial industry that is concerned with producing food, but also the consumer folks who are interested in preserving their gardens from all the creepy, crawly, nasty critters that are out there trying to destroy our gardens. So then the degree day models, we have models for many, many different insects, particularly those that are agriculturally important. But we also use degree day models to predict some disease outbreaks. So for instance, apple scab, when I talked to you about diseases during that lecture, we mentioned apple scab, that fungus that affects apple trees and crabapple trees and a lot of plants in the rose family. Fire blight, that is a bacterial disease that also affects plants in the rose family. Sooty blotch and fly speck, also again apple pests. And there are, for orchardists, various computer models that have been designed, and they have various applications and monitoring devices that are put up in an orchard to be able to monitor the temperature and the relative humidity and how long a leaf is wet, for example, to try and predict when apple scab will be at a point where it's an outbreak. Now they have a similar sort of, it's called Blightcast, that it's a monitoring program for figuring out when late blight is going to be possibly an issue on potatoes. And I get a weekly update from our vegetable specialists. There's a newsletter that talks about what sites are now at risk and what you should start spraying and so on. So diseases, insects, all of these, they use degree days as well as phenology to help predict when those things are going to be around and what we can do about it. Okay, so that is the last slide. I'll be talking this week about organic techniques, and phenology and degree days are part of the techniques that we use as organic growers to help try and protect our plants from insects and diseases and stay ahead of the curve. So I'll be asking for questions in class, and I'll be giving the lecture in class for organic techniques as well as annuals. We'll be doing a lawn activity, and we probably won't be able to look at annuals because we're so darn behind this year that most of the annuals are not planted at this time. Usually by this time I can do that, but not so much this year. Thanks for listening, and we'll see you in class.